down for. But we'll see.
Well, I can always go into city council mode and be quite, I can talk to people that are on fire.
I
Um,
I mean, I would love to have this conversation on the tavern. I think it's a great and appropriate place to have this kind of a conversation too, because it is one of those things it's really touchy and it's a hard conversation to have. Just because there's
yes,
so
and
much to it, right?
yeah, and emotion stuff. But
I think there's a lot of
she
things that
has
people don't really want to hear, right? You know what I
she
mean?
has her emotions too.
Oh, true.
But she gets the right to dance, and she's certainly
Spicy.
cooking up a gig. Yes, yes. So we should mention that previously you were almost right last time about the volcano starting. But did we decide? I'm trying to remember the prediction. We don't write down our predictions, but did we predict that the thing would still be erupting?
Yeah, we both said it would still be erupting. I said it was gonna like pop out the side.
Ah, yes, yes. Well, I imagine Maanyaa is she on the inside of black holes booping the edge? Is
I
that
think
the?
she's inside the volcano at this point.
Oh, she's gone to volcanoes.
Yeah, it's just
That,
moving
that,
around.
that'd be, well, I hope if she comes back soon to let us know what's happening. Which
She
volcano?
she may or may not be swimming and trying to swim in lava.
Yes, yeah. Swimming in lava is not recommended.
Not recommended. 2 out of 10.
Yes.
Would not fap again.
Oh, it's starting.
Hello, hi, welcome back to Debate Hub, everybody. We're here to talk more about volcanoes. I'm here with Landon. We were having some spicy conversation in the background that you guys missed out on.
Yes, yes, yes. Fortunately, the microphones are only turned on when we're ready to that because we would never want to be less than professional on this show. Uh,
Yes, you can. This is only a professional show where I, your host, Chesh, the master debater, do nothing but serious things all the time.
yeah,
But the mics don't turn on until that bubble pops up. That's how that works, right?
yeah.
Pretty sure that's how I set it up.
So I think that's the way it is. Well, they can tell us in a chat room. Hi, chat room.
Hello, chat.
We
Can you hear
should.
us okay? Everybody got audio?
If ever got this the stuff here,
Nice
maybe
and
I should also
balanced.
look at the chat
We both
thing,
got
or do you
our
want to?
we both got our little dudes going. My guy's not doing
Oh yes,
anything yet.
yeah. Well, mine. I was here late. It's in the stage where the magma chamber, the heat source, is currently melting the lava. So it will begin to bloop once it starts melting through.
Mine's not
Um,
quite
it's
blooping yet.
but
Can that be the new
speaking of
official term for
bloop,
their bloopers?
yes, yes. I don't have much in the way of bloopers, but they'll go eventually. But speaking of blooping things, um, as of December, the number was 46 bloopers on the blooping things, at least geological blooping things, I believe. If you look at the
Volcanoes are now
list,
officially called bloopers.
so 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 Europe, Atlantic Ocean. You have the two constants, Mount Stromboli and Mount Etna of Italy. So Italy's got its two of actively erupting, and Stromboli is known as the lighthouse of the Mediterranean. It's sort of almost it's one of those things like Kilauea. It's like all the time kind of stuff. And Etna has been putting out some really nice fountains recently. Um,
Brian in the
uh,
chat said about swimming in lava, said, I make it a habit not to swim in substances denser than I am. And I would like to point out, I appreciate that, but there's very few things on this earth that are denser than I am.
yeah, so Iceland doesn't have any erupting volcanoes. Africa Indian Ocean, there's one in Ethiopia and one in Democratic Republic of Congo.
Nice.
Indonesia currently tops the list with 6 erupting
Ooh.
volcanoes. It's a very
Indonesia getting
it's a
jiggy
very
with it.
volcany type things. Um, Nothing currently in Alaska or North America. Um, but Mexico, Central America, there is one in Mexico, two in Guatemala, and one in Nicaragua that are erupting right now. South America, Colombia one, Ecuador has two, Peru has one. And then, of course, there's the perennial Mount Erebus in Antarctica that's still got its nice lava lake. I think its lava lake is probably, there's a debate about whether or not the Erebus lava lake is bigger than Pele's Halemaumau area, but
I think
that's
chat
a
is gonna kill me today just because Icarus said don't swim in young Earth creationists then.
yes, yes. And don't swim in the fluids that cause the continents to zip around like air hockey pucks
I really don't want to
during
talk
the
about
flood.
young Earth creationists and their fluids.
No, 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 no. That discussion would evolve into things that would get us demonetized.
I'm dead today. I can't exist this day. So anyway, sorry, I interrupted a
Yeah.
little bit, but Maanyaa, by the way, is not here. She will be back next week. I'm not sure if she will be
Yay.
on Friday or Saturday because I'm pretty sure that's like right when she's getting back. So I don't know if she's gonna be like jet lagged or if she's gonna get back and just be like, "Let me on." She might.
Yeah.
She might.
It'll be depend upon Maanyaa as it usually does.
I mean, listen, she's never
Well,
allowed
Maanyaa.
leaving me for this long again. I haven't been able to handle this past month at all. I've been
No.
falling apart. I'm over here
Yes,
watching all
and
this stupid, and I'm like,
and the DFF, all the great things that Maanyaa brings to this channel.
yeah.
So, but continuing on the list of I'm talking about the
Yes.
principal, the principal spots. In Pacific Ocean, we have Kilauea still erupting, and Vanuatu has a volcano erupting, and in the Philippines, it's got 4 erupting at the moment. So those are kind of the big ones there, but there's actually 46 currently in the process of erupting. If you're talking about stuff coming out. So you're talking about actual active lava versus erupting with fumaroles and those sorts of things coming forward. Indonesia continues to be the most eruptive. It actually has, I'm correcting, actually has 5, and there's 6. It has 6 with lava spewing. And I hope to, after the solar eclipse off the coast of Australia, to go and visit a couple of those volcanoes, right, and see them stuff. But that's for another day. So Madam Pele in Hawaii.
Yes. So last time on Dragon Ball Z, Madam Pele was erupting quite what would you call that? Would you call that aggressively? It wasn't like massive, but it was like
it was a vigorous fountain.
Yes.
Yeah.
Yes.
And it certainly but also it had a reasonable amount of gas out. Remember, magma being liquid rock would prefer to do what things with mass does, head towards the center, right? That is fall down. and it comes up.
Fall down.
Actually, technically speaking, the magma stays the same and the ground accelerates up because gravity is not a force.
It is uppity rather than droppity.
Yes. So when your cat takes the object and nudges it off the table, it's conducting Newtonian experiments, right? If you and it's correct, if you apply a force to something, it'll it's at rest, it'll start moving, it'll continue to move until another force acts upon it. Well, that's what your cat's doing. They're doing these Newtonian things, and if they were in like the space station or something out there, they would do the boop, and it would just basically continue to go until it hit the wall of the space station.
Has there been a cat on the space station yet?
That would be pretty interesting. I would imagine the cat would like freak out, and stuff would come out both ends.
To be fair, cats freak out if you like sneeze the wrong way.
or place things like zucchinis next to them. They seem to react to zucchinis.
Landon's been watching
Um,
memes.
well, no, I know cats. Right? We had a thing, and cats would get freak out when we bring the zucchini from the garden into the shed. They would there's something in their brain that says
That's not okay.
really bad, really bad.
Mm.
Anyway, so you have the thing where the cat is going and nudging things on the table. They're just doing these Newtonian things of saying, well, this is Newton still right? They're performing an experiment. Now, if you then say, well, the cat pushed the table onto the floor and caused them to crash, you are blaming the wrong thing, right? In an inertial frame, the cat just pushed off the edge, and it continues to move in a straight line. But due to a curved space, what actually happens is the floor rushes up to meet it.
Oh.
So when I drop this thing, boop, like that, I apply no force to it. I let go. It stays the same.
Oh,
You
okay.
think there's a gravitational force yanking it down, right? That's the old Newtonian magic thing. But Einstein said, no. This thing stays the same. And what happens is the floor rushes up to hit it. So when the cat pushes your favorite coffee mug off the table, they're performing a Newtonian experiment, and it's the fault of the floor accelerating up and hitting your coffee mug.
Oh.
Not the cat's fault.
So the cats know this. But the cat's like, no. The floor is gonna make it up fast enough that it's just gonna keep going, and it just doesn't.
Yes.
I see.
Because cats and relativity are very important, and I won't go into there. But for my proof of equals mc squared, we use a cat in space that glows. But that's another story. Oh, I think isn't this about volcanoes?
Yeah.
Sorry, so. Chat. We got sidelined. So Kilauea. So yes, it is still erupting, and particular thing that I think is important and impressive is that the amount of gas we were talking about magma that wants to sink down, but why does it turn into lava coming out on the surface? Why do things inflate? Well, because there's dissolved gases inside that magma that boil, form bubbles, and that fizz, that bubble gives it loft, right? And so the just like you have soda that's in a can under pressure, right? It stays there, but when the pressure begins to release, those bubbles come out of solution, and if you do it violently enough, it goes boom out the top of your can or bottle and creates a mess. And that's what a volcanic eruption is just magma creating a mess, or not, or nice things if you like lava. So
all a matter of perspective.
But remember the other thing that happens with that magma is that so the magma comes to so why does the gases in it boil? Why doesn't it boil deep down? Well, as you move towards the surface, the pressure drops. You have less stuff above the surface pushing down, right? As you head towards the surface from deep out, you have less and less pressure. The pressure drops to the point where when you reach the top of the rock, the only thing pushing down on you is the weight of the atmosphere, 1 atmosphere pressure.
So
fair minus,
well, yeah, like what happens to water when it's condensed, or what happens to steam when you condense it?
And in fact, it'll if you give enough pressure in certain conditions, it'll turn liquid or even go to solid, depending on conditions. But that's there's exotic things. There's actually exotic temperatures where if it's hot enough, it'll do weird things. But that's
what is
normal.
What is an exotic temperature? Is that just a temperature that we don't find here naturally?
I think it's when things begin to behave in unusual ways. For example, there is a pressure, or there's a temperature below which or above which you can't condense steam, water vapor, to make a liquid. It'll just simply say, I'm not going to go into liquid. I'm still
just nopes.
Yes. But if you force it hard enough, you can force it into a crystalline structure, right? There's many phases of water. for example, many phases of the stuff. The typical things of solid, liquid, gas, the kind of normal terrestrial stuff, is those phases. There's actually turns out to be many states of matter, not just solid, liquid, gas.
As a Canadian, I can assure you that there is definitely more than just rain or snow.
Yes, there's poutine.
And slushing.
And double doubles at Timmy's.
Double doubles. Never forget the double doubles.
Yes,
one of the most important.
Most important thing, yes.
Yeah. No, that is double doubles are one of the most important things in Canada. That is a term you have to know if you live here.
But the thing I find that some Canadians don't know is that double, which refers to the amount of sugary substance and amount of dairy substance put into coffee. There's a gentleman who was saying, "Well, I do a double, but I get 2 smalls because I want less."
Would you like some coffee in your sugar?
And the problem, and it was a sad thing to do, because I, as a Yank, when he was explaining this to me, said, I believe if you asked the lady who's actually making your coffee, that they dose it. When you say a double, you get a double dose of
it's a machine. You press the button, the amount comes out. If you say 2, they put 2 pumps.
Yeah. So when you actually ask for a small, you have a small amount of coffee with the same amount of sweetener.
Yep, milk and sugar.
And I said, so it turns out that you are getting much more sweet concentrated stuff by having 2 smalls. That's equivalent to, and then the lady says, yes, a normal medium double, you are getting 2 smalls. That's as if you did a quad on a thing. And in fact, you're getting much higher.
Yeah, a 4x4
glucose.
We call them 4x4s. I don't know if they do that everywhere in Canada, but in Ontario, we call a quad is a 4x4.
Yeah, and double is a little bit, in my opinion, is a little bit too much sweetener stuff. So I guess it's a single double I would prefer, or even
I usually get 1 sugar and 2 milk, usually, but that's in tea.
Would it be a single double?
I usually get that well, I get that in like a large or an extra large. Yeah. So it's like barely any. Anyway, Tim Hortons.
we were. Oh, that's right. This is a volcano show.
This is a volcano show. Me and Landon have to do a show where we just can hang out, chat about whatever.
So we're talking about the magma, and why does magma come to the surface, work its way against the gravitational field of the warped space-time thing, due to all that mass down there? Why does it come up, and then why does it fall back down? And part of it is that as the magma has gases in it, right? There's gassy stuff down there. There's water, there's carbon dioxide, there's sulfur dioxide, there's chlorine compounds, all kinds of other stuff in there. And under pressure, those things would be a gas are under so much pressure they turn into liquid.
Right.
In some cases, even a solid. But different things have different boiling points. Yep. So down below, there's a material that has a higher boiling point, which means it can go from liquid to gas deeper down. And so that begins to boil and begins to push the magma up towards the surface, right? Because of the buoyancy is pushing there. And then now pressure drops even more, and more gas comes out, and basically comes out and accelerates and goes poof. And normally, if everything were just kind of static, you'd have basically a burp, or fart, depending on what you think is going on a volcano. Gas would come out, and that'd be the end of it.
Yeah.
But
that makes sense.
But that's not really what happens. First of all, the gas doesn't boil instantaneously. Everything, right?
Right.
There's latent stuff. Even the stuff that's even the lava that's on the surface has gassy stuff in it. Have you
Yeah,
seen
and like
pumice?
and heat disperses, right? So
Yeah,
whatever gas is coming up is going to take heat with it, and that's going to change the temperature of whatever's inside the lava. And it's not like it's
exactly.
stationary;
Yeah,
it's
that
constantly
that
moving.
and you've seen pumice. Right? What's pumice? Pumice is basically this very light rocky foam with gas trapped into it. It's a,
It's
basically
like
it's,
this.
it's
It's
the
like the
foam.
gross side sea foam that you see when the tide goes in and out, and it smells funny.
Yes, or it's the foam on top of your latte or whatever. It's and
Landon hasn't had his
there's
coffee this morning.
well, I do have my Kilauea mug, and I have what would be considered a two zero sugar two cream,
Yeah, there you
but
go.
but
Feline in the chat is asking if magma can also be plasmic deep enough down.
taken plasma. No, I mean the Earth doesn't have the type of temperatures that would send the material into a plasma state.
Is that due
Plasma.
to our size? Like if the planet were bigger?
Well, the problem, of course, is that as you get if it's bigger, when you go deeper, the pressure would get more intense. And in planets like Jupiter and Saturn, the pressure is so intense that the gas turns into solid, right? And so we know now from things we've been whizzing around both Jupiter and Saturn that there's a rocky core in the center, but around that rocky core is a material of hydrogen that is under so much pressure it's turned into a metal.
That's
It's become
crazy.
it's gone metal, right? It's no longer nice
It's gone to
baroque
plaid.
plasma. It's now heavy. It's done heavy metal. Right? It's
Right.
doing metal thrashing stuff, and by that metal, I'm doing a pun here, but the metallic hydrogen has currents flowing in it. I mean, there's all these electrons going through this regular grid of stuff, and there's a contaminant, so it has kind of like the similar things as semiconductor stuff, where it's got areas where it does things. There's also helium down there that gets conducted into liquid and maybe even solid, and you get these helium hydrogen slushies that behave in weird quantum mechanical ways and so forth. So you get really extreme stuff if you get big enough. The pressure gets so big. On our Earth, the rock which is coming out of Kilauea and on ocean floors, even the deep rock that we can get access to, is the light foamy silica stuff, like silica dioxide, right? We typically think of rock as heavy, but let me tell you, a chunk of iron or a chunk of nickel, that's heavy, that's dense.
Right.
And ironically, so deeper in the Earth, the what's riding on the stuff towards the center is kind of this little pond scum, this lighter silica stuff,
Right.
that's floating on top. Those are the continents and the ocean plates and so forth. Underneath there, when you go down deeper, you find much more of heavy materials. So you find your irons, your nickels.
That's
You
what
also
mining
find
is for.
uranium, thorium, other things down there, and it gets down as you get closer to the center of the Earth. The temperatures rise to the point where they're about the same temperature as the surface of the sun.
Okay. That's hot.
Yeah, that's toasty. There's a lot of Kelvin
Spicy.
there
Yeah.
to go around, and at that stage, where it gets at that temperature, the iron, even though it's under tremendous pressure, is in liquid form. So you get iron nickel material in quite molten form. Where did heat come from? Well, part of it was when things smashed together to form the Earth. That collision, there's latent heat giving away, right? And part of it also that there's radioactive material. So there's a lot of uranium turning to thorium and decaying. The radioactive processes are also keeping it warm. So you have the crust, the mantle, which is kind of rocky stuff. You get this liquid material of these metals in Earth. And that's, by the way, how the magnetic fields form, because you get currents going on literally inside the liquid stuff. But if you keep going deeper, you hit something solid again.
Right.
at the very towards the very center. The even though it's very high temperature, the pressure is so extreme that it's no longer going to remain liquid and goes to solid, right? So you're not deep in the earth, you have basically a solid core. So you got a solid core surrounded by a liquid core, liquid ring, surrounded by a slushy lower mantle, followed by a somewhat squishy upper mantle, followed by the wiggly pond bits that float on the top, which is the crust and all the things that Kilauea is doing. And that's, part of, so Earth size is important, so important because the dense stuff sinks towards the center, and typically, but there's still convections, there's still stuff, that gases that come up and push it. So inside the Earth, there's these currents that push stuff up. And that's where the continents begin to slide, because you got mantle currents
Pressure
pushing against stuff, right? And we see the hot spot inside, so somewhere down deep, there's a material that's hotter, maybe because there's a little bit more radioactive stuff there. It's not really quite understood, but the ocean continent is right over the top, and where the hot spot is, it kind of melts its way through and creates volcanoes like Hawaii. Other places where the continents collide, they also melt and do things.
Right, so that's a lot of pressure, and that's a lot of friction, and that's going to create a lot of heat.
So if you doubled Earth's mass, you'd probably have a larger solid core, because the kind of materials wouldn't get to the stage where you could create,
It can't get between point A and point B.
You would be pressured, you start to solidify stuff there. But anyway, so back to the thing about the magma, right? Where stuff is boiling, as it comes up, different things starts to boil as it push it toward the surface, which causes the pressure to drop, and more stuff boils.
Yeah, and
at some point,
if anybody's ever watched a pot boiling with a lid on, it can get pretty chaotic, and that's just with one material, let alone multiple materials.
Yeah. So when we look at a volcano erupting, one of the things you want to do is to look at the gas coming out, because that's going to tell you what's boiling.
Right.
The gas is also a kind of a precursor to, or a predictor of how much energy is coming up, right? When a volcano's gas output drops way down, that's a sign there's less stuff reaching the surface, boiling, coming out. That's a sign that the not that eruption is stopping, but the eruption is slowing down because you have less loft.
Right.
And
the pressure is coming down.
So the magma comes to the surface, and when it boils and stuff goes whoosh, most of it doesn't come up to the top. Most of it just sits there, fizzes, and now you have this sort of stale magma, which doesn't have the loft, and it does what it does in Earth's warped space-time. It begins to sink, right? And because it no longer has it's outgassed, right? A lot of the stuff, not everything, but outgassed. So that stale, we call it stale magma, begins to sink, and it kind of fights the other magma when it go up, right? You get this thing that sort of comes up, fizzes, get a lot of fountaining, and then the fountaining kind of dies down because it's kind of put out a lot of its stuff, and it begins its gas, and it begins to sink down, fighting the other magma, waiting its turn, right? And eventually, what happens is that you get kind of turnover, where the kind of thing comes to this side, this goes to this side, and they flip around. The denser magma sinks, and now all of a sudden, that turnover causes you now have magma to rapidly rise, because it's now going to flip, and now it has less pressure, and now it goes poof, and so you see these cycles happening. And when you watch the fountains, right, the active thing, it'll go through cycles, maybe 5-minute, 10-minute, 15-minute cycles of it. A lot of fountaining. Now that magma begins to sink down in, fight the stuff coming up, it kind of dies down, turns over. And so, but why does it turn over? Well, because there's still material from below coming up. from material that is lowering where stuff is melting or boiling. Those are two things that will push it up. And so the amount of gas coming out is a sign of how much energy is coming in.
There's also a change in temperature, right? And fast changes in temperature can cause a lot of energy, essentially.
Exactly. Right. And
I've got at least two brain cells that I can rub together.
Yeah. These turnover things.
My brain runs on static electricity.
Some of the, but we still have electrons moving around inside your brain. Yeah. So the turnover areas are what we call magma chambers, right? It's not just a thin straw coming to the top. There's areas where when they do that fighting, they kind of melt stuff around there, and so you have.
It's the lava lamps. It's the lava lamps of coming up and then coming down. It bloops up and then goes down and switches.
See? We got a bloop there, and so it did its thing, and it'll take a while for it to. But that cycle is there, and so a volcano typically has more than one magma chamber. We're most influenced by the magma chamber near the top, but there's another magma chamber feeding the upper magma chamber, and so forth. Then it depends on whether you're in the ocean or so forth. It's quite complex. So when we look at what's happening in Kilauea, and I say, the sulfur dioxide rate was approximately 3,000 tons per day. And that rate has sort of stayed the same since January 20th when they measured it. That is a sign that there's still a lot of stuff, a lot of dissolved gases turning into vapor and making the way to the surface. And it's continued to be that way, saying that there's still a lot of stuff much deeper coming into Kilauea's magma chamber. And but right now we're in this odd state, historically speaking. The big lava pool we'll see normally would be covered by rock. It would be fairly flat. Right. And that would be the upper magma chamber. Because at the end of 2018, when you had that great 35.5-year eruption period, and towards the end, it worked its way down the spine, the eastern going spine of the rift zone, and came out to the very end of the island, right?
Yep.
And you had almost a kilometer of lava just go down there. Well, that came from the magma chamber, which was near the surface. That magma chamber had basically had a hole, and the top caved in.
Right.
But as Pele tends to be a nice, gentle volcano, not cranky, tends to not be so cranky, that cave-in occurred over several weeks as opposed to one massive collapse, right? Remember, volcanoes tend to be their most dangerous when they implode, when they fall in.
Right. That's what we had talked about with Yellowstone, right?
Yeah. Or any sort of thing that happens, right? Yeah. And even the Tonga eruption, right? It's a little bit hard it's a little bit counterintuitive. You see, but the Tonga eruption was a big boom, right? One of the bigger booms we've seen in the last century plus. But remember, what happened in Tonga is the top fell in, and you now had a bit of ocean water falling into a magma chamber.
Huge temperature change, huge amounts of displacement,
and gas going from liquid to vapor, and
it's similar to dropping like an ice cube into a water, like a full water.
Yeah.
Out it goes.
Yeah. So and also it's like you're getting that reaction of putting something into a drink, and you get the fizz.
Taking your drink out of the freezer and opening it and watching it just frost immediately.
Yeah. So what's happening in Kilauea now, and it's important to see, is that what you see of the great lava lake at Halemaumau is really would normally be inside a magma chamber. That would be the magma chamber, that giant sort of hourglass blob that's slowly filling up. Right. That would be a magma chamber with rock over the top.
Right.
And perhaps if pressure got high enough, you get little cracks and little spews coming out on the top, right? If it got I know.
Brian makes a
Um,
good point, like dropping a frozen turkey in a deep fryer that's turned up to max
yes,
heat. Yeah, that would do it.
yes,
Even just water.
yes,
Don't put water in a deep fryer. Don't do it.
yes. Yeah, yeah, don't do it. Um, but you can also get things where if you have your liquid nitrogen, you put dump you take a relatively warm chunk of ice and plunge it into liquid nitrogen. You'll get a
Right.
violent boiling, and it'll don't do that
Yes,
either.
the
Um,
relatively warm piece of ice. Correct.
yes. So so
Everything is relative.
So what we're seeing now, this phase of Kilauea, is we're seeing the top of what normally be a magma chamber, which is why it's kind of acting kind of different than the normal course of things. We have a lower magma chamber feeding upper magma chamber. At some point, it's going to crust over, maybe because there's not enough as much material coming up. The ebb and flow of the deeper stuff coming up might change, allow the eruption to slow down, even stop, crust over. Um, so, some point it's going to resume its normal thing. But in
Right.
some ways, that giant blob that's in Halimamo is kind of in a semi-liquid state. It's beginning to form the crust of a magma chamber below. And it's getting hard for material to break through the bottom of the magma chamber into the top of the magma chamber. It'll still continue to grow.
Right.
But another thing is to understand that most volcanoes don't most of their expansion, most of their bloating does not come from lava on the surface. That may be like 1% of its volume.
Right.
Most of it is internal magma
It's like
pushing
a
its way up
glacier.
inside.
It's bigger on bottom side.
Or like you've got it. You're
It's like
baking a
me.
cake and you have a.
I'm bigger on the bottom side.
Well, that's a relative term. But you're pouring batter into a mold, and the bread just sort of expands from the inside
Right.
up. Now, some of the expansion will cause cracks where stuff will get up to the top. Most of what makes a volcano get bigger is stuff on the inside pushing inside, giving it that loft. And it's when the magma gives up and no longer pushes and drains that you get a thick crust that the stuff drains, and now you get a hole, and then the thing falls in, and then it really goes boom, right? That's so just a quick little reminder of what's happening here, and why, for example, the amount of sulfur dioxide coming out is a good proxy for how energetic is it. The other thing we look at is tilt meters.
Right.
Let's look at the tilt meter stuff.
Real quick though, if it starts
Yeah,
forming that crust around that chamber, is that likely? Is there a likelihood that the volcano will then settle down into that, or is it more likely that the volcano is going to potentially get more violent?
well, two things can happen. I mean, one of the things it can do is that
Use the term violent
because
loosely.
if you get a thicker crust, it gets harder for the magma to get up through the thicker crust. It might push on the inside underneath the pond,
Spread out.
the forming crust, right? Also remember, in the shape of the magma chamber, it's this martini glass set of stuff. So it's got this dome over the top, which is kind of this semi-liquid state to slushy state. And if there's less energy coming in for a period of time, they'll allow that top to freeze even more, make it more difficult for the stuff to get all the way to the surface, and will again start pushing to the side. Also remember, as you predicted but didn't happen,
Yet.
Volcanoes have spines, and the rift zone that can either go towards the southeast or the southwest are cracks along the spine of the shield volcano that are weak points that magma can travel down in. And for many years, Pu'o'o, a side vent, drained lots of a lot of the lava would come up near the surface of Holy Mountain and had a hole in the top. The lava would just come up near the surface and say, oh, hi, and then duck down through the tubes.
I'm sneaking out.
We now know from the collapse that as are predicted, that Pele has sinuses, right? There were these little chambers of stuff where we would see gas coming out. So we say, okay, it's getting more vigorous, but why aren't we seeing a fountain come out the top?
Right.
Well, it's because it had little side pockets, little sinuses that was filling up, and also was draining out down the spine. At some point, one would then expect, if the volcano continues to behave the way it historically has done, that cap of the top of the magma chamber, which is now naked, we can see in the top of it, will rise up high enough that it's easier for the magma, instead of breaking through the crust, to go out one of the tubes. And the fact that the collapse at the summit kind of collapsed a lot of the sinus chambers, there's less nooks and crannies for the magma to push into, and more for one of those rift zones to go down. And even the pipes that sent it to the far south east corner of the island, those pipes were almost a kilometer down below the surface. So you just have to get enough melting and enough crust on the top to force it to the side that it'll likely enter that stuff. So, but we know at some point that magma chamber top will reach the surface, right? That's the equilibrium. When we used to have the 3 by 5 kilometer nice flat caldera, you could walk around and those stuff, because you had a lot of rock between you and the magma chamber below. That was the equilibrium point where the kind of balance point between the magma when you get out, but having this lid on it to keep it down so it would go out the sides. That's usually the way the volcano behaves. So we're watching this magma chamber in the process of forming, and we expect at some point, because eruptions ebb and flow, when there's less energy coming into the system, that the eruption will slow down, it'll cross over more, and it'll begin to build the bottom of the magma chamber and start to push out, we think. Right? But how long that takes is anyone guess, because it's an unusual phase of having a naked magma chamber open to the top. So let's look at the wiggly lines, right? The tilt meters. This is the tilt
lines on
stuff.
paper.
And so if we come into here, we'll zoom into the spot.
There you go. Nice.
This spike here was about a month ago when the eruption started.
Yep.
That was a big thing where Pele waited until our show ended and then erupted, because she wants to teach us a lesson about humility.
I mean, just the fact that this is called poo raw data.
Yeah. Yes. So those that is the POOWE are the locations for the tilt meter. So POO stands for POO, and other one is Wakehana Station, WED, right here. You see the two. So the POO station is no longer reporting, because that used to be the side vent where it had a lot of stuff going. Now it's frozen solid and there's not eruption there, so I'm not putting that line.
Oh, okay.
In.
That makes sense.
This is the blue line, is the one near the top, near in the. It's actually it's on the western rim of the caldera, and that's the kind of primary tilt meter. So we saw this big boom, and that was when we thought that the eruption had stopped, and in fact, it was just a pause. I take it that the eruption kind of paused because the lid was holding it down,
right?
And it broke through. Right, that's when you had enough pressure underneath that it began to
pop
crack,
like a zip,
the earthquake, and that's the pop there. And so these things down below, because they're kind of scaled, are showing you these deflation and inflation. Remember I said the magma comes towards the surface. It outgasses, right? So it inflates, and then that magma gets stale and begins to sink. And so it sinks back down, and then you get a turnover, and the new stuff comes up again. So this is like this breathing thing, back and forth, gives you the sign about how much energy is coming in up through the system. And so we see from the data that, when we had the show week after to celebrate the fact that Chess was mostly right, that it did go bang, although not in a big bang, but just it went it erupted, right?
It went bang enough. I'm gonna gloat.
Yes, you're mostly right there. So in that sense, the you
That
see
means
the deflation
nothing. I
inflation.
have no idea what I'm talking about.
We're pretty regularly, but then we ran into this phase where the deflation inflation events are kind of weak, right?
Right.
And in fact, if you look at the past week, we only really have had one turnover, right?
And it's really
This is
slow.
a sticking in, coming up, it's slowing down. And today, you might say, is this a sort of minor little turnover? Because it's not a single thing, right? But it hasn't been as vigorous as before, right? From
The beginning of January.
after the eruption.
Yeah.
Now, this is a tilt meter responding to the upper magma chamber, right?
Right.
There's a lower magma chamber even deeper that is having its own turnover. So what may be happening is that just prior to the beginning of this event, or I would say at the beginning of an episode, because I'm beginning to think the eruption never stopped. This was a phase change, right? When it began the new phase, the lower magma chamber, much deeper, had already turned over and its gas was working its way up.
Oh, okay.
And went to the upper magma chamber, which is naked, all exposed on the top,
right,
and went out, right? And this normally, if we had a solid crust over the top, we would see the inflation. We might even see a bit
some
of
of
stuff
the gas coming out, yeah,
but not to the extent that it does now. It'd be a magma chamber filling event.
Right.
And so the lower magma chamber was still pushing up lots of material. Why? Because we'd see the DEI event. And now it's kind of slowed down a bit. I think it would be a mistake to say the eruption is stopping.
Mm-hmm.
Pele could decide after the show, I'm done, and cease for a number of years. Yeah. That being Pele can do what she wants. This may be a sign that the lower magma chamber has going through its
already
cycle
done this
of turning over, and we just have to wait for its dense stuff is sinking down. It's not sinking as much stuff up, but once the turnover completes, then we'll get a resurgence of material coming up again.
Lava lamps are way too good of an example of exactly what we're talking about, and aptly named.
Yeah. You see, we got a little bit of eruption there on the side of this one now.
Yeah.
And when the back has done its thing, so yeah, well, they do their
doing nothing.
So when you look at this data, I see that the amount of sulfur dioxide coming out, 3,000 tons, is still pretty good, right? If it was in the 100-ton range, then I'd say there's not as much stuff up. It seems to be slowing down.
It's still certainly there is plenty of movement.
Absolutely. And so the fact that it's not turning over as fast on a daily basis may simply be a factor for the lower magma chamber having to complete its turnover before it sends up into the upper magma chamber. It's like a double boiler type of thing. Now, if you look at the summit distance, this is now not tilt meter, but the two fixed points on the caldera and using GPS, a very high precision GPS, much more precise than your phone.
Good. I don't want my phone to be that precise.
and we saw at the top this little spike here that it was expanding. The mountain was expanding. So this is not the upper magma chamber, because that's now kind of open, open, exposed. The lower magma chamber pushing up against the top, right? Remember, volcanoes mostly expand by the inside. Of stuff that never reaches the surface. So it kept expanding. It reached kind of a pinnacle when, I just say, it popped and stuff came on the surface, and that released under the pressure and it sunk back down just a little bit. Seems like it's going down a little bit. Again, you got to be careful to read into this stuff.
It's still early. If it like March all the way to June was that expansion, and just coming down a little bit from January does not mean it's going to start swooping back up again.
Yeah. There are little gaps because sometimes we lose telemetry because the Pele tends to be hard on instruments. She likes to eat them as little snacks.
Oh, what's this somebody left for me? Crunch.
Well, she
Little
figures
cream filled kind.
we're putting out offerings and she's accepting those offerings with good grace. So yeah. And in fact, some of the things, the cameras you see later on are cameras that were used in astronomical observatories that are given to the USGS because they're underfunded. And so when a camera goes out because Pele eats it or it has other, and if it eats it, by the way, it's not just lava, right? You can get, there's all kinds of acidic gases coming out that kind of tend to corrode things. So you need to replace cameras and instruments on a basis. So that's where those gaps are from. But if you look at the 5 years, this is the 5 year tilt. This is the big end of the eruption. Right? This big drop. That was the summit collapsing, right? And it collapsed. The sides of the caldera shrunk by almost almost 3 meters, right? Now
this is in 2018 for anybody.
That's over a span of about 3 or 4 kilometers.
And this is between March and September of 2018.
Yes, this is the end of that 35-year eruption where the magma was moving rapidly down out of the magma chamber, upper magma chamber, rapidly down the spine and came out to the end of the island. And then the summit collapsed in. And then it stayed quiet and it erupted for a brief period of time. That was near Christmas time, the day after Christmas, where it kind of caught us by surprise and
2020
and erupted for a bit. And then we had another one here where then it sort of seemed to kind of smolder around, and it appeared to briefly stop here, but again, I think it just went through a phase.
You can see that there is a regular upward trend over the past 5 years.
Yes, and so that's
by regular.
The thing here,
I don't mean like the eruptions are happening regularly. They do seem a little bit irregular to us, but the overall trend is.
And this may be again the talking about the amount of material, amount of energy coming from deeper in up through the stuff, which takes time to get to the surface. It doesn't instantaneously decide I'm going to come on the surface and become lava, right?
Right.
So is this downward trend just a little blip like this thing, or is it a longer term drop, right? Because if so on the one hand, we still have a lot of gas coming out the top, and the magma chamber, which is now the surface, exposed and naked, is still expanding. If we had a normal crust over the top, we would probably be seeing, if there was lava on the surface, the lava would stop, and you get a bit of gas coming out, but then the rock kind of congeals and seals it off, and you have to build back pressure before it pops.
By the time we get to the annual of this show, I'm gonna be able to just do the next round of teaching everybody about volcanoes.
Absolutely. So this is sort of volcano stuff that's happening. So we look at the instrumentation, and for me, it appears with a tilt meter and so forth. Yeah, the tilt meters are temporarily sagging down, but I would want.
They're also probably measuring the wrong thing. Yeah.
I want to see it DI events slowing down, and going down, being longer between DI events, and less gas coming out the surface before I would say it seems like it's slowing down. So maps. Here's a current map of the caldera. To give you a little bit of orientation, this area here is the larger caldera. This is the big thing that used to have nice trails walking around. And Holy Mountain used to be a small little bathtub drain here, hole here. But it collapsed, right? This all fell in. And remember, this particular this lava lake is 3.2 billion gallons, or over 12 million cubic meters of stuff. This is a deep lake.
At the furthest length, how many washing machines across is it?
You're talking about this thing here. I mean, it seems like, given this is 300 meters, and is a washing machine a meter?
I don't know.
So
They're
this is
different
300
depending on
washing
where you go.
machines. So 3, 6, 9. This is like, a kilometer and a half wide. So that's like 1,500 washing machines side by
Yeah, it
side.
says at the bottom here the lava volume is 3.2 billion gallons.
Yes.
The active lake extends 27 acres or 11 hectares, and full lava is an extent of 292 acres or 118 hectares. The crater floor
So
is
the
listed as 2,940 feet or 896 meters above sea level.
Yeah. So talking about this bottom here.
Yep.
So this sort of pinkish area is the crusted lava that came out from the beginning of the eruption on January 5th.
Smitty said
Um,
metric or imperial washing machines.
well, aren't imperial washing machines what the servants do for your clothes because you're a lord or lady?
That's the maid's job. I don't know.
Um,
Hoity-toity.
you have to ask. You have to ask your if you're a Tory, you have to ask your valet.
Talk to your butler.
Yes. They'll be able to advise you. Who will probably say, my lord, you don't need to worry about such things. The plebes will take care of you.
The plebeians will take care of you in this trying time. Do you prefer
Yes.
Downy or do you prefer Snuggies?
Yes. Anyway, back to volcanoes. So when you talk about this 200, 118 hectares, right? This is this large sort of salmon colored thing. This is the lava lake, and the actual active vent is over here. So this
Right.
red is the active. There's a lake here. We'll see a picture of that, and a lake here, and there's a little vents. The big vent here is kind of the current stuff. So this is the fairly active part of the current eruption. Now, this isn't to say this isn't still lava. It's just kind of pasty lava stuff.
I don't know, but
And
imperial washing machines wash imaginary clothes.
because does the emperor's new clothes, are they invisible?
Chat's gonna ruin me today.
Oh, anyway, so meanwhile,
Oh boy.
the floor of this lava lake has risen 9 meters. That's
Right.
30 feet for those that are metrically challenged. Since January 5th, since the new phase of the eruption started. So this large area here has gone up 9 meters. Not because there's so much stuff coming to the top, but because underneath it's pushing the red loaf is proofing. It's puffing up. So that gives you a notion that there's still a lot of pressure that
Right.
this kind of top of the magma chamber is resisting against. Eventually, when this thing is higher and higher, and it's going to take more and more volume just to expand. This is going to eventually kind of somewhat fill in this hole. It may still be like Kilauea, a kind of a little indentation, but that magma chamber it'll get harder and harder for the magma to come up to the top and become lava. It'll resist more and more the internal pressures feeding in from the magma chambers below, and it may melt its way into the tubes going this way or that way. Remember, here's over here, this spot. Here's the top of the summit, and this dark line is the spine. This is the other spine. Over the 35-year eruption, the magma was going out here and coming out Pu-O to the side, but eventually it works its way all to the bottom and came out here. It hasn't been since 1970 that's gone this direction, but both of these are viable. When the summit collapsed, the question is, did this tube kind of become overly restricted and making it possible for the magma to go this direction? See, there's cracks going this way. It can go both ways.
Pele's a switch.
But there you go. Pinch hitter if you're into that baseball thing.
That baseball thing. Sports.
Well, you say it's a they're
Yeah,
pinch hitter
yeah.
because the pitcher can't bat, so they put a designated batter in if you're in that one league,
Hmm.
or they're one of the ones that are can switch on which side of the plate they're on because they want to annoy and confuse the pitcher. Um, so this is the state of affairs right now. And by the way, you can go to stay at the national park, and there's all these overlooks here
This is our
that are
obligatory
there.
go and visit the national parks and our
Yeah,
regular advertisement for go to Hawaii.
yeah. The Volcano House. Last I looked in February, it was fully booked because people like to come in and watch it. Even if you don't see go to the overlook to look down into the magma chamber. At night, the glow from the magma chamber creates this nice glowy thing. It's like Spider-Man sending a glow to the clouds. It's quite a nice sight. Here's what it looks like thermally, right? So we can see at the beginning of the eruption, a lot of lava. Here's January 6th. A lot of lava came out here around the side. It had this lake here, but it had the big pond. It kind of slowed down to here. Most of what we're seeing is this one lake where near where Gillings Island kind of used to be. It's getting harder to see the island. It's kind of getting covered over. And there's this other more active lake where the fountain is, and you see a little dot there. There's a little kind of new island that's near the fountain. It's kind of odd that it's kind of in.
Oh, they're like side by side.
But it seems like this the old islands seem to have gone away. So that's kind of the current from the maps. So pictures, right? Here is a nice picture. Here is Mauna Loa way in the background. That's not a little hill. That's the most massive volcano, active volcano in the world. But you can see the drop down block, and you can see sort of how this is a little bit domed.
This is clearly a dragon's footprint.
Yes, it is definitely. And there's the kind of the hot spots, multiple hot spots there. A lot of gas coming out, even gas coming out over here as well. As I say, getting to it would be very, very difficult because you got a lot of cracky, unstable stuff.
Yeah.
It's going to be a while before you get trails.
This was all stuff that we were watching move not too long ago.
Yeah.
We were live watching it move if you want to go check out a previous video.
Yeah. Here is a zooming in on the one of the sets here from the big spot. And again, so you can see that there is, this is still lava. It's not as fresh. This is relatively fresh lava. This is actually actively moving lava here. So you need to understand that lava is not the red glowy bits. Those are the high temperature lava that's more liquid. Right. This is still oozing and moving.
Yep.
Here's another view from there. So you see the main vent and a couple of side eruptive vents going on, but there's also stuff going over here.
Yeah, and look at it all. A lot of gas.
And you can see that it's got, this is the top of the old caldera surface, not the top. This is the top of the mountain, but it's got a ways to go from here to here in terms of filling up. Another looking down onto the set here, one of the active spillways, but another active spill over here. Here is that island, the Gilligan's Island here. So for those that are Gilligan's Island fans, there it is. But it's you can see this stuff is getting encroaching on it, and I suspect at some point it might be covered over, especially if this thing continues to go the way it goes. So here's a picture of the vent, and there's this little island that seems to be. It's odd that a lot of stuff is coming out here, but there's this island floating around going.
One little cold spot.
I think it's doing the do-to-dos, right? That's sort of it's popping around.
This is the whooper in the GIF. This is the whooper that everybody's drowning, and the whooper's just like, this is great.
You can see there's other little chunks floating around too for that, not just the one chunk. And also notice there's a bathtub ring, right? So one of the things that happens sometimes is that because the lava rates kind of ebb and flow. You get a push and then kind of a slow down, and those cycles can be 10 minutes, 20 minutes, 30 minutes. You get these sort of pushes of stuff. The material slides over the surface and congeals, comes up to the top and kind of stops, right? And the result is you get this little ring, bathtub ring around it, the little thing where it kind of comes up, splashes up against it, and stops. Yeah, like that. Just going do.
Do.
But these bathtub rings are a thing that happens sometimes with lava ponds. The lava comes out to the extent where it begins to freeze, and then it kind of splashes up against a little rise and adds more of that bathtub ring when you don't clean your bathtub, and you know who you are because I've been in your bathtub. Not when you were there.
I'm that island. I'm the island. Everything's on fire around me. This is fine.
The islands are fine. The islands are little toys in your bath, right? It's the caked on brown stuff around the ring of the bathtub.
Ew.
Yes,
that was the stuff when I was cleaning up when I first got to this place.
Yes.
Yeah.
So that's what this ring is around here. We're going to see the bathtub ring. Here's another closer look at some of these little islands.
Letty says that's a spicy creme brulee, pokes the crust, dies.
Yes. Still lots of gas coming out, lots of cracks here. At night, this will be glowing. You see a lot more of these stuff. Again, all this is lava. These are rocks, but all this is lava, not just the red stuff. I can tell you times, when they are doing doesnt stuff and people come in and say, where's the lava? And I try to say, that's all lava there. It's just in different forms.
I can understand people confusing me for a crusty island. I'm pretty crusty.
Here's that other spot, and you go back to the map here.
Yeah, where is that?
So sure, it's this spot here.
Oh, right? Okay. Yeah. All right.
Before when we thought that the eruption kind of stopped, but it paused. This was the little lava lake. There was a fountain, little lava lake, and surrounded by the island, right? From the Gilligan's Islands is in this center. So that was that spot. But here we're seeing this spot where the stuff would come up here to the top, go and sink back down in. So there's
now that looks like a bathtub.
Yes. But it has spills, occasionally overflows and spills out on the floor because people get I want to point out there's a bird down here.
Yeah, what the hell? I was gonna ask about that if that was just like.
I'm sorry to say that bird, the curiosity killed the bird.
Yeah, that bird's not living through that.
The bird went down to kind of investigate. It found a lack of oxygen, and instead of flying the hell away, decided that is getting exhausted and would go down and land. And somewhere between not breathing and
melting,
baking,
baked bird.
Yeah.
Baking and asphyxiation. Take your pick. Yeah. I also wonder how much that might have been also impact damage as well. But
now
yeah.
this bird here turned out to be much closer. This is up near the top, so that bird was not deep down inside. That was in line of sight from.
Do we have any idea what kind of bird it was? Very white.
I don't know. I'm not an expert on tropical birds. I apologize. But you can see more.
There it is.
You see
the bird's still there.
That's a different bird, the same species, but it was actually closer to the observer, up high. So
okay.
Stay out of the pit where.
So that's just how big that is. That bird is actually closer.
Yeah. It's got this nice long tail thing too. So they're fun little birds.
Scale is going out of my brain.
But bird is much closer than this spot here.
Yes.
And you can see again the bathtub ring here. from this pond kind of going up, lapping in this. You have these
Edge of the brownie.
waves of lava that hits the side of the colder stuff and freezing.
I like that it does operate kind of the way like a beach would, but instead it just
Yeah.
crusts and stays, and then crusts and stays,
Yeah.
and then crusts and stays.
So you can see
And the layers.
here's this sort of dike, beach dike there with these are the waves from the ocean coming
Yep.
up, lapping against it, freezing. But occasionally the bathtub ring overflows and you get
The bird
stuff
again.
oozing out. Oh yeah. Again, that's a bird. So I'm told those birds are made it because they were actually closer to the observer.
So like they saw their friend, they were like, "Yeah, dude, yeah, definitely go check it out. It'll be fine. Yeah, don't worry about it. You got this. Yeah, you're fine. And bye."
But the fountain there is still quite active.
Yeah, look at that.
Most
cool.
of the material coming up through there and all the cracky bits going forward. From the point of view of earthquakes, whoops, let me expand in here to look again in Hawaii. And you get
this isn't as bad as it was before, yeah.
In Mauna Kea. Nothing happening much on Mauna Loa. Here is the last 7 days. The summit of Kilauea. This is the one spine this way, another spine that way, right? And so we see that there's a couple of earthquakes down here. These earthquakes are likely pressure from the previous eruption where the rock is kind of sliding there.
Settling
They're not
into place.
Sign of magma pushing its way down. They're more like a settling stuff. This pile down here is that deep magma chamber that feeds the seamount down here, the volcano here, and Mauna Loa and Kilauea, right? So this popping down here, but these are deep quakes,
right,
are a sign that there's a much deeper magma chamber. That's kind of
the chamber you were talking about earlier.
This is kind of where the hot spot is actually feeding. But you might think about the hot spot is kind of here, and so it kind of equally services seamount here and here. Hotspot is slowly by geologic terms moving this way, or the crust is moving the other way. It kind of depends on where your point of view is. But again, most earthquake activity is not at the top from stuff falling in or going bang, but deeper down, materials still going up there. So it's suggesting that we're going to be quite active. We've still got a lot of activity going. As to whether stuff as magma is rising or sinking, we believe it's rising because we continue to see gases coming off the top.
Puck, what are you yelling about, buddy?
Puck is voicing
he has opinions,
commentary on what Pele's doing.
Yeah,
but from a day perspective, it looks like this. I mean, this is the day stuff. And there's a couple of things these are basically island kind of sagging, but this is the magma chamber deeper coming up. Lots of I captured this picture showing at night what things look like. You can see at night. This is a freeze frame of this camera where you get lots of glowy stuff there. So it's not only just this, but this is this little waves of lava hitting the shore of the bathtub ring. This is the larger of the caldera. You can see that other spot, and you can see thermally what it looks like. So you got this lake and this lake, but also have these little other spots, hot spots. There's little pockets of things around there. That was just because it had rain on it. From the far side, from where you would see from the like Volcano House, you see the glow of the chamber.
Very cool.
There, and it's really nice when you get cloud there, where you get the red glow up against the base of the clouds.
Yeah, I like that yellow one. The on the left. Yeah. That's super cool.
Yeah.
I like the colors. That's like the kind of picture that I would take to color pick off of if I was painting something. I'd be like, I like those colors. I'm going to take this picture. Thank you, colors.
Yes. So here's another example of I took out the night again of the thing going for that. So you see that spot here. Now, when you actually visit the cam, because this is obviously late at night, this is Hawaii time. This is a can and have it reload. This is the, let me go back here. This is what it looks like now,
Ooh,
right?
it's still splashing around
Right?
quite a bit. Sloshing.
And there's that little island. And that island seems to have moved away.
Yeah.
The currents have pushed it away, so showing it's not anchored
Yeah.
at the bottom. There is another sample looking down the camera of all the stuff. Again, nighttime glow is quite nice. But if we reload it today, we see there's that big pond with the
Ooh.
little islands in it.
It's almost starting to look like a crater.
Yeah, I mean it's somewhat, but it's deceptive. This is basically this is the bathtub ring around the pond that occasionally breaks out in. But you can see that it still has a ways to go up before it starts going into that inner part of the drop down block.
Yeah. There's still quite a ways to go.
Right,
now,
that's this spot down here, right?
Yeah.
Where we're seeing coming down this way. So back.
Now, this might be a question that's for you and Dapper maybe combined. So if anybody's following Dapper's channel, I think he's gonna be live at some point soon. If you guys can do me a favor and ask him a question about in the like down the line in the future, how do you tell geologically between what's a crater and what's been a volcano?
Yeah, because sometimes you have events of volcanic events where there's one-time shots, right? Particularly as a mountain goes into dormant phases, it has these still pockets of magma, that liquid, that are being, as the thing is freezing, being squeezed, and literally it's a one-time zit pop, right? So dormant volcanoes like Mauna Kea, where the telescopes are littered with little, look like zits, right? Because it's a thing where as the dormant, the magma chamber is no longer being actively fed with energy, so it's in a process of cooling and contracting, and occasionally that compression causes a gas pocket to force it to the top, and you get a temporary eruption, but there's no feeding into that, so you have a kind of one-time event of Puck sitting there looking lovely.
He's having a he is in his element right now. Somebody sent him some chewies a little while ago, and he's just having the last one, and he is enjoying it.
Hi, Puck. Cutie pie. So yes, so there's a lower drop down block. This spot here, from perspective, is in the map is this spot down here. Oh, excuse me, this spot down here. See the drop down block?
Yes.
So when you see this thing, you're seeing the drop down block. It has to go up higher in order to reach the surface. From a gas perspective, the air quality is relatively good, except for sometimes in the top here's the caldera. So we're not getting really unhealthy gas coming out.
That's good.
But you can see here that the trend, that the trade winds is very typical trade winds in this area of the world, where the winds move to the southwest. So the gas coming out of Halemaumau tends to go across here, and this area here is a very desert. Not only is it drier than most of the other parts of Hawaii, but it has also this acid rain that makes hard for stuff to grow.
I just
so
realized
here's
the reason it's so dark in my room is because I never turn the light on.
Well, isn't that, do goblins prefer the dark?
I mean, sometimes. There we go.
Yeah. So here is a spot where we're going to play the active. Here's the active live camera. And I'm going to take this time to go to the bathroom.
Go have your own eruption.
And and so but kind of watch the ooze off the thing there, and you can entertain them.
Yeah,
or maybe tell them about.
Actually, let's just let them watch this for a minute. Check it out.
Yeah.
He didn't hit play. We're boned. All of our plans brought to ruin. No! Landon! I don't have anything to entertain you guys with. I'm sorry. Puck's here. He's cute. You know what? Hold on. Let me see if I can. Can we get like a really good. There you go, Puck. Entertain the people. You beautiful bastard.
Oh, I'm sorry. It it I'm sorry. It paused when I put down my headphones. I apologize for that. Let's let it. I'm not hearing you, Chesh. By the way.
Ah!
There you go. There you go.
It's okay. It's
I
just me
early
panicking. Don't worry about it.
when I walked away, so you didn't get to see. So we get to give them more active lava times.
There we go.
But
There we go.
again, in terms of in terms of size, if we go back to the map, we're talking about this red area here. So this is almost like almost like about 200 meters by about 250 by 500 meters. So in washing machines, is it square washing machines
Square. I
or
mean,
imperial square?
oh, Imperial washing machine squared.
But yeah, it's giving you the size and stuff. So this is probably about 250 meters across, top to bottom, and about 500 meters side to side, in terms of size. So this is, these are things are sometimes shooting up maybe 20, 30 meters at their highest blooping stuff. But again, we can watch the ebb and flow of this thing going there. It's the gas is moving away from the camera, so it's not as bad. The fuzzy stuff that comes from the fact all the thermal things come off of it.
And you can still
But
see
at
it's
night,
kind of doing that wavy bit too, right?
yes. At night, oh yeah. Sometimes it's again, it sometimes it gets more active and then it kind of dies down. There's a minor cycle near the top and a major cycle.
Cubic washing machine for
There.
volume. Yeah.
And it is interesting that this island has kind of been pushed away from the vent, but you kind of expect it, as that's how fluids work.
Yeah, fair, makes sense.
Yeah, it really
that
does.
tracks. Have you guys ever
and it's
watched
fun
a rice cooker? Because a rice
Tell us about
cooker,
it.
a rice cooker does something kind of the same thing. If you ever actually like sit and watch your rice cooker, if you put the lid on it, it will bubble, and sometimes if there's enough water in it, depending on how big your rice cooker is, it will like bubble around the very top. So it'll come out a little bit as it steams,
Mm-hmm.
but sometimes you'll get like around the ring of the lid. Some of it'll bubble through and it'll get this film around the outside that is like
Wow.
from what's in your
And a big bloop. I was just saying.
big bloops. Um,
Yes.
and so, but you'll also see like as the rice kind of like expands and starts to take shape, you get like these little holes, like little divots of where the water has broken through, like this overlay of the rice from what the water is underneath the rice and what water is above the rice.
Oh,
Rice
rice
cookers.
cooker. So is this a rock cooker? Is
I
that?
mean, it seems like the same kind of concept. I don't know.
Yes. But I want folks as you're watching this stuff to understand what a privilege it is to see, first of all, an active erupting volcano is not cranky, that you can get up close to it with relative safety. Its lava is actually inside an open magma chamber. So we're watching the magma chamber fill from without a lid on, and it is quite extraordinary that this can be done. And again, it sounds like I'm from the Hawaii Tourist Board, but you never hear me say go to Oahu and go to Waikiki Beach and Diamond Head and places like that are.
He's like, don't go to the commercial places; they suck.
Yeah, it's like saying I've been to Toronto, so I know what Canada's like.
I went to the ACC. I went to the Toronto Convention Center one time.
Yes,
I saw Leaf
yes,
games at Madison Square.
yes. Um, so
I went to a hockey game in Tampa, Florida, and got poutine. I've basically been to Canada.
yeah, going. I don't know. Seeing hockey played in a place that's not natural is odd. But did you know there's a hockey team on the Big Island?
Oh, a Hawaii hockey team?
Yeah, there's a Silicon Valley guy who retired there. He spent some of his money to build a hockey rink, and
That's
there's like
cool.
locals that skate. And I can
Nice.
tell you that some of the Polynesian folks there, authentic Polynesians, are come in Polynesian style, right? If you've ever seen, there's these types of Polynesians that are just massive, right? And they're not massive because they're tubby tubs. They're massive because they're big. I mean, they are truly, as Cartman says, big bone. I mean, these people are large, muscular, very active folks,
Yeah.
and it's interesting to see a Polynesian goaltender because they kind of fuck out
Listen, there
of
is
the
no net. There is only goalie. I would love
um,
so much to see a hockey game in Hawaii. I didn't watch. Okay, I can tell I'm Canadian because I haven't followed hockey for years. And I went to
is that allowed?
yeah, I was busy and didn't
Oh,
have
okay.
cable.
All right.
So
Okay.
I went to a sports bar with my stepdad and my mom, and we were at the bar, and or no, sorry, it wasn't at the bar. I was at their house because they have a bar upstairs. I went to their house, and he had put on the hockey game, and it was Toronto versus somebody, I can't remember who, and it was during the playoffs, and I got so invested, and I was just like, what the what
It's your
I'm so
Canadian DNA coming
I'm
out.
just sitting there being like, this was wrong, this was wrong, this guy needed to pass over here, this ref call was bullshit. I'm like, I haven't watched in
Yes.
years. I
Yeah.
got legitimately angry at the way the game was being presented by the people, like by the hosts, because I was like, are you
Wow.
kidding? Or you just missed that? I think it was actually Florida. I'm pretty sure it was Tampa, Florida versus Toronto. And I was just like,
Yeah.
listen, Florida should have lost that game. And it was the
And
ref.
I must admit my approach to hockey is somewhat different than an usual fan. For example,
Hmm.
I do not like fighting in hockey. And if we're up to me, you get if you drop your gloves, it's a game misconduct suspension for several
Ooh, that's
games,
harsh.
right?
Ooh.
Um, and stuff, and basically to say so that the teams that hire the thug to go out and pound on the other team because the
Oh
refs
yeah.
aren't doing their job,
Yeah,
right?
yeah, yep,
I,
yep.
I understand that mechanics, but that's a ref failure. It's also a game failure because you're not seeing quality hockey. You're seeing people being frustrated because they can't play quality
If
hockey because stuff
yeah,
isn't being called.
if
Right?
you wanna, I wish slashing had a higher penalty to it. Slashing is
Yes.
really, really bad.
Yes.
But
Yes. Don't slash
I recommend.
unless you're the person slash and you're playing guitar. That's a different
That's
story.
fair. I absolutely recommend if you want to see like real hockey played really, really well, watch the women's team. The women's
Yes.
Canadian hockey teams are so fucking good and they do not get enough coverage.
Yeah, and
They're
I have a very
fantastic.
good friend of mine who is now getting her PhD in library science, and she was a goaltender, who's Canadian, and she was actually, but she played during the days when they didn't have quite so much protective gear,
Yeah.
um, and the other thing is her knees bend in
Yeah.
ways that are not natural.
Yeah. Yeah, hockey will do that to you. Hockey will
Uh,
fuck you up. It is not exactly the most pleasant sport. It is contact after all.
But this lady did not take. She worked in Silicon Valley, and she did not take crap from Silicon Valley nerds. I mean, she'd board somebody in the hallway if they were.
Oh my
I
god. Amazing.
you
I
you you
aspire.
did not put your hands on her without permission because she took care of herself.
Lay you out. Yeah. Yeah.
Yeah.
Respect.
But back to the thing. So I like a well played game
Oh,
where the refs do their job to
yes.
call things, but there's a minimum amount of penalties because there's a minimum amount of crap going on. It's
Right.
when the game degenerates and you start to get, if you get refs that are doing their job and having to call penalties all the time, that's where the players are
Yeah.
kind of come unglued and gone away from hockey fundamentals and are trying to push stuff. And the
Yeah.
question is whether fighting goes out, whether the team thinks that they're being prevented from the result of a good team. Because I think if a
Yeah,
team plays
penalties are
hockey
inherently
well, they should have a score result
yeah.
that comes with playing it well.
Penalties are inherently designed to put one team at an advantage because one team tried to take an unfair advantage. That's basically
Yeah,
the how it works.
but but it's hard from a fan because you'll see something happen that the refs don't call. They
Yep.
don't see or they choose not to call. And then the other team responds aggressively.
And then
And
they
it's
get called.
often the person retaliating it gets called. And you say, well, how come? Da, 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 da. And so then they
Yeah.
go and try to do the reverse, and then and the
Yep.
game degrades
Do
into to
not get
just
me do not get me in a room watching hockey. It doesn't matter if I like the team, hate the team. I will sit there and I will nitpick the shit out of it. And I haven't watched it in years.
yes. So it is an interesting sport, and I do women's hockey. Another thing is some of the
Mhm.
college
Oh
hockey
yeah.
are in that level
Yeah.
has really good skilled people playing really skilled game because it's hard. It's
Yeah.
I consider it a victory if I'm on skates and I'm not falling most of the time. That's that's
So
my level of play.
there's something really cool going on. Okay, so now I need to go skating in Hawaii with Landon.
But it is a
And
thing.
we'll
So
watch a
so
Hawaii
there's
hockey
a.
game.
I mean, it's not really a league. It's a bunch of expats and Polynesians who sort of convinced to try and put on skates, and they
Yeah, hell
they
yeah.
they they, they get around inside because it's such an anachronism in Hawaii.
Is
Um,
Chesh more
and
toxic playing League of Legends or watching hockey? And Smitty also asked how drunk I was. By the end of the game, I had a few beers in me.
yeah,
Am I more toxic playing
uh,
LOL or watching hockey?
at
I don't
this
know.
at this rink, they have a person who makes wonderful mai tais. So instead of
Ooh.
beer in hockey, it's mai tais, and
Ooh.
and the Mai Tais are accelerated with the amount of. I mean, at the end, again, in the Polynesian sense, by the end of the game, people are sort of just chilling out and having fun and like, yeah, do we need to? We want to continue playing
Meanwhile,
now?
in Montreal, there's a riot before the game even started.
Yes,
So there's some cool stuff going on with this volcano here. You can actually see the what looks like is supposed to be like the crust is
yes,
making its way
it's oozing.
downtown. It's oozy
Yeah,
blooping.
but it also is expanding slowly from underneath, and it's doing its thing. So
Like
so
some of
yes.
this is
Now
pretty like vivacious.
I will say that I discovered this team because at night when the park service wasn't looking, someone brought a catapult, and the catapult was to take the puck from the one team that won the championship, and is their victory, victory thing,
That's cool.
1 point thing, and the puck was literally put into the catapult, and the catapult launched it into to Pele's
I would
holy
now
mama.
I want nothing more than a Hawaiian team to win the Stanley Cup and they can launch the Stanley Cup into the volcano.
That
Please.
that might be
Frowned
um
upon.
would would it consider, because that I must say, on the other hand, other sports can learn from trophies, right? Stanley
Oh,
Cup is
sure.
one really nice, classy trophy. It is a
Launch it
beautiful.
into the volcano.
I can tell you that the and the team that wins gets to take the cup around, for charity events, and every player has a certain amount of time they can bring it to their home place or whatever it is, and
Yeah, they get
and
to
and
bring it
and
around
it tours around as a nice PR thing. I can tell you
into
that
the volcano.
what I did, because several times the Stanley Cup, actual real Stanley Cup, came to our Silicon Valley campus.
Oh, nice.
Is we used the dish as a Wi-Fi reflector. So we didn't touch the cup, right? Because we're not allowed to
Not
touch
allowed
it,
to
right?
touch it. Look
Yeah,
with your eyes, not with your hands.
but we took electromagnetic, things, and use it to bounce into the from top, and then send basically the Wi-Fi signal out to basically do a Wi-Fi broadcasting. So it became a little Wi-Fi broadcaster thing. To do what? To show basically the camera of people who want to look at the cup, or watch people who are going there and visiting and paying us homages, or things like that. So
April said
that's the one thing.
If Jamaicans can bobsled, Hawaiians can play hockey. Listen, anybody can play hockey. But they need a
Yes.
Canadian coach if they want to win. Because that was John Candy.
And but I say it is a fun thing for them to do. And the park service kind of looks the other way when they launch. For both thankful for the previous season, and looking for the next season of launching hockey pucks into the spot.
No, Puck, we're not going to launch you into the volcano.
No, it's a different puck.
Should we launch you into the volcano when you're dead? Would you like
Yes.
that?
And I, by the way, I always presumed that you named Puck after the Puck as opposed to the Shakespeare character.
It came from a few different places, but it came from a mixture of he's black on the top and white on the bottom, kind of like a Puck on ice, but also Shakespeare Puck. Also Gargoyles Puck, which is also Shakespeare Puck.
Okay.
Gargoyles.
Sure. Sure.
There's also we do have a couple of volcano questions from the chat because I wanted to let a couple of them get through. We've got Feline asking, how can it be that allegedly this also played a part in catastrophic plate tectonics or possibly hydroplate tectonics?
So I presume there's a little bit of tongue in cheek about the catastrophic plate tectonics, which was an excuse for certain creationists to try to explain the continents, because there's a certain weird young Earth excuse to say that at one time before the flood there was one giant continent, and then somehow things broke up during the flood, right? But we know that not to be the case, because the amount of energy involved in continental motion is extraordinary. The amount of momentum energy, and that energy, if it happened during the flood, or even on the order of years as opposed to 100 millions of years, the energy from the friction generated would turn the surface into plasma, right? It would be hotter than the surface of the sun. And it would just
I was gonna say the surface of the sun is now us. Huzzah.
However, if you're pushing dogma rather than facts, if you're somebody who is a grifter, like let's say Kent or the Harkin Gunner people,
there's
right?
no getting away from
there to extract money from gullible people because you're the gullible person, you're the person who's gulling them, then facts don't matter,
right?
And because you're coming with dogma, you're not coming up with facts. So now, that being said, I think let's take the other side of the coin of the question being asked, which is, where does the energy come from continents moving? And the answer is that the forces that cause continents and ocean crusts, which are thinner, more basaltic blocks, the energy of that motion comes from the mantle underneath, where you have upwelling from the hotter core area that tends to rise and build convection cells, right? So just like in boiling water, you might get something coming up where the material rises, reaches the surface, and spreads out, right? And that spreading, that vortice stuff, will cause, like in the mid-Atlantic, plates to break apart. Stuff comes up from the top because that volcanic ridge along the stuff. Whereas, places like Africa, North America slide away from it because there's this convection system going like that. There's other areas where it is subducts, right? So you get things going under things, but all that energy comes from the motion of stuff in the mantle. Where does that come from? Well, it comes from the heat, and the heat from towards the center of the Earth is in two forms. The original energy, when stuff kind of came together to form the Earth, is part of it, but the other part is radioactivity. I mean, the Earth has lots of uranium. Uranium half-life is we're certainly less active, but 3.8 billion year half-life of uranium, still, atoms breaking apart and pieces shooting off causes the stuff to bang around, and you basically get you generate heat. So the combination of latent heat from the formation plus the reactivity is where the source of heat from the inside that causes the upwelling, and that upwelling pushes on continents and causes them to slide around. And the continents go through a cycle, right? Right now they're kind of broken up. Previously, we had a single piece they're called Maanyaa that's broken to Gondwanaland, and then the continent's going to break up, but they sort of slide around, and they come back around and congeal in, run into each other again. Just like, for example, India took off from Antarctica and slammed into Asia, and the crumple zone is the Himalayas.
Very cool.
And beautiful places like Kashmir are some of the most gorgeous populated places on Earth. But those are sort of the energy of the minimum of those continents is driven by ultimately a combination of radioactivity and the heat of stuff. Now, a planet like Mars is smaller. It is more landlocked. It doesn't have quite as active a mantle, and so why? Because it's surface area to volume. Small things have, because you're going to radiate heat away from your surface to cool down, and smaller things have less volume for their surface area, right, than the Earth, right? So Mars being smaller cool down faster, and it isn't as geologically active as Earth does, right? But Earth is
Right.
wiggly, wobbly. We've got what 46
Blooping.
volcanoes right now. It's a Earth is still pretty good, but over time that'll decay, right? And
Right.
and primarily we think it's going to be a combination of the original heat of formation, Earth cooling down, radiating its heat, plus the radioactive decay of things like uranium that are going to cause the the center of the Earth to become colder, and eventually at some point it's going to turn into a slushy bit, not an active blooping bot, but a slushy thing. At that point, what you're going to get is super volcanoes, right? When the continent's no longer, like the Pacific plate is not really moving that fast, but you still have a hot spot, you're going to get a super Mauna Loa building up, right? Because it's no longer moving, and so you get a lot of stuff coming up the top, and that's when you get the Olympus Mons type things. Mars is the biggest volcano we know of in the solar system is on Mars, because its plate kind of locked up, and it put out a lot of stuff in this hotspot. Eventually, Earth will do that. At some point, these hotspots will not be moving relative to the crust because there's not that mantle convecting. Things will kind of lock into place, and it will push out lots of material and build really big supervolcanoes. Because Mars is supervolcano stuff, and it has several
Yellowstone, eat your heart
enormous
out.
of stuff. Its volcanoes move up into Mars' stratosphere. I mean, it is
Right.
the Olympus Mons and those things are there. So we'll get eventually a super volcano, several of them, that'll push itself up even beyond the extent of the into the stratosphere. But that'll take a little while for them to happen. Meanwhile, it'll continue to bloop around. But yeah, it's the heat, and there's a debate about how much of this heat came from the early formation, because stuff slamming together generates lots of heat, right? That collision of forming the dust bunny was there. Also, if our model of how the Earth formed is reasonably correct, and it seems to be so far, about 50 to 75 million years after most of Earth came together, we got hit by an object that was maybe about a quarter size, if it's the size of the Earth. Another object that was kind of rogue, moving around, slammed to Earth. The two slammed together and vaporized, right? And in fact, the bullet that hit the Earth, destroyed early proto-Earth in the bullet. It kind of vaporized. It moved its way through the Earth, and would have kept on going, but it didn't have enough escape velocity, right? If it had been really going fast, it would have gone through, bang through there, and kept on going.
Right.
But it didn't. It lost a lot of momentum, and the escape velocity held onto it. That blob or blobs ended up forming a ring like Saturn that quickly congealed to a blob, which became the moon.
Spoilers. Moon. Cheese.
So yes, it's a lump of cheese, and that was a surprising thing, because the moon seems to in some ways be very different than Earth in terms of its density, and it doesn't have a magnetic field to speak of. It's much lighter, and so when we were excited when the Apollo 11 people brought back rock to see what this moon thing is with no atmosphere, and we found the rock was Earth-like.
Right.
Very, very Earth-like in its stuff. Yeah, there was occasionally they found a meteorite of a chunk of other things hitting the moon.
And
but for the most part, the moon and the Earth share a common origin. It's just a lighter, fluffier stuff. It used to be. But anyway, that was part of the set. But that collision helped build up a heat, but it vaporized all the really dense stuff, uranium, which is a pretty heavy metal, nickel, iron stuff, all that stuff just sunk towards the center. And so all the radioactive concentration, we've got a nice stratified core that's more radioactive than normal, which gives us lots of heat in the interior, which gives us lots of mantle convection, which gives us lots of motion of crusty stuff and volcanoes and other wonderful things.
I would like to point out that this has been brought to you by a sassy comment about Kent Hovind's Hydra stupid theory thing.
Yes.
um,
I would recommend watching Dapper's
yes,
channel for stuff,
absolutely.
because in addition to poking fun at some of the silly things that some of these so-called creation science people say, Dapper explains what we know there, so you can learn a lot
Yeah,
about language, about biology, about
history.
craters, origin stuff. I mean, it's a pretty good channel.
And to be
But
clear, there was a poll, and the poll was: is the moon cheese vegan, or is it just from all the cows jumping
oh.
over? 10.7% of people said it was vegan.
Oh,
67.9% said it was jumping cows, and 21.4% said other.
that would be in Dapper's language. I like turtles.
Yes, correct.
Yes, but that's a Dapper thing. So what are the other questions that the chat has?
We
Let's try to
have
get some.
Okay, we have one other question, but we only have 10 minutes left.
Okay.
Can you do
All right,
it?
so let's do some rapid. Let's do. And by the way, if you have other questions, we'll do some rapid
Yes,
question and
please
answer things.
yes,
So
tag me if you have a question now to make sure that I get it. Okay, Athens had asked right near the beginning of the stream, how much trash can we throw into a volcano before it becomes too toxic for the earth or humans?
be a lot, because there's a lot of material that comes up through a volcano, and it tends to also, the
It'd be like
heat
an
would tend to
incinerator.
detrash the trash. Yes.
Yeah.
So it'd have to be. I mean, I don't think people
Ultimate
generate enough
recycle
trash.
ultimate recycling. Take all the trash, throw it in the volcano, it incinerates it down to its core pieces, and then releases it as gas.
Yeah, there was a one time a serious proposal to dump trash into places where it's subducting, where because it upwells like this, but at some other place it's doing this,
Right.
converging, right? And you get those trenches like the Maanyaa Trench. And some people thought, well, you dump things down there because eventually it'll subduct into the earth and get mixed up. But part of the discouragement of that is that the bottom of those trenches are active biological zones, and you'd be basically pooping in someone else's home. Now, fish do that all the time, but the ocean full of fish poop is part of its biological process, right? They don't need our poop added to it.
Right.
Now, so you want to minimize the amount of
that would be
trash.
would you consider like sludge or like sewage with that? So we would take that out, but there's like trash would be something potentially different. Trash being like pop cans and tabs
Plastic
and
and
bottles and bags,
Well, for
potpourri.
example, and I'll describe something that didn't happen.
Sure.
You know what a
Yeah.
plumb bob is? It's a weight with a pointy bit,
Yes.
right? There's the top cap and the bottom cap, and it's nice. It's nice aerodynamic shape, and it's made of metals that came from Earth, so it's a natural thing. And I did not, fitting the two together, put some of my mother's ash between the two, so that when I was allegedly sailing over the Maanyaa Trench and dropped it pointwise into the ocean, where it would have traveled many kilometers down, achieving a very high rate of speed
Yep.
that would have hit the ocean floor, many kilometers down at a pretty good rate, and would have drilled deep into the mud, because it would have amused my mom. She wanted me to consider spreading her ashes into interesting places right into water.
That was
So I did
definitely
not do.
interesting. I'll give you that.
I did not do that. That never happened.
Yeah, no. That would have been cool though. Um
But yes. Other
uh
questions. So rapid questions
what
now.
about nuclear waste?
Yes, and here's a problem that there's a lot of radioactivity in the ocean, right?
Mhm.
Everything from, there's radioactive stuff on land. I mean, thorium, uranium are very common elements in your backyard. Dig up a cubic meter of material, and you've got a couple grams of thorium, uranium in there, just because it's natural stuff. So radioactivity washes into the ocean. all kinds of stuff there. So in some ways, the ocean has radioactive bits in it. Do we need to add more to it? Probably not. And as well as what you really don't want is material with short half-life that's very concentrated, causing problems, especially if it falls off the back of the truck in the middle of Western Australia. You don't want to do that, right? That's the thing. If it's spread out over a place, it's just natural background. And so some people have suggested, well, stick stuff into the trench because eventually geologically it'll subduct into the ground. But the things living down there, it's not sterile, might object to you effectively nuclear pooping into their backyard.
That's fair. That's fair.
I mean,
is trash, is garbage actually that big of a problem? Because
yes
I hear both things, right? Like sometimes I hear, yes, it's a really big problem, but it seems to be a localized problem, not a global problem in the same way, I guess. I don't know. Maybe I'm just interpreting it wrong.
I've traveled a lot in Africa, and it's rather common to find areas where, those plastic trash bags used to give out in grocery stores?
Mm-hmm.
You'd find that trash plastic all over the place, right? Where it might have gone to a landfill and blown off, or someone dropped it on the side of the road, or it's been thrown away, put a landfill, and the wind blows it. And so you see these places where these tree lines or bushes where there's trash bags stuck to the bushes out in the middle of nowhere, blown by something. So the trash can be unsightly. I also know that certain critters can ingest that trash or get trapped in trash, and it's not nice. Particularly if you like turtles. There's some bad things that can happen with turtles with trash. There's ponds of trash, areas in the ocean where floating stuff tend to congeal. Just like in lava, we get little islands where you get islands of trash floating there. It isn't very nice. It doesn't look good. It bothers a lot of the critters, and it's just generally not a nice thing to do. So you could say, well, everything that's trash came from the earth, but
that's just an excuse.
But
it's an excuse to be lazy.
On the other hand, pick up your trash and dispose of it properly, right? Even when you go to Hawaii, a nice place like this.
Well, okay, I think that's a little bit of a different question, because littering is different from just trash production. Sure. Right? And so if the trash is being disposed of properly, is what we're doing currently on a global scale appropriate? And how big of a problem is it? Because sometimes it seems to be getting, I don't know, maybe fear-mongered, people but I don't have a good scale personally.
Yes, and it's very sort of what kind of trash it is. Sure. And also some of that trash can be mined for recycled materials when the prices get right. And so some places will take an old dump and start going through the old dump and recovering those or actually probably imperial washing machine, right? Because there's a bunch of metal you can then melt down and do for other stuff, right? That's a reuse of things. There's a lot of
there's definitely value. There's definitely value in reusing and recycling metals, for sure.
Yes. And so trash mining is there's an industry but it's subject to the prices, because if it comes cheaper to just get new aluminum from the aluminum plant, then aluminum can recycling isn't. It's kind of an ebb and flow of
it's economics. It's trash economics, garbage economics, the economics of garbage.
That do a lot of recycling, right? That try to minimize the stuff in the waste stream and try to reuse stuff. The spot market for copper, for aluminum, for tin, for other metals, plastics, those things, ebbs and flows. And so if you're trying to make money off of the trash, you sometimes need to accumulate material, because if a whole bunch of people dump in, let's say, tin cans and metal cans onto the market, such that you get a glut of metals, so the price of metal falls, it becomes not economical. So instead, what you're able to do is to accumulate that material on the side, hold it in a pattern, wait for the price to correct and rise, and then slowly put it back out. That's sort of so people who do the recycling on the on supplying the materials back to the center, pay attention to spot prices and that sort of thing.
Very nice. Okay, we should probably wrap up there. Recycling is cool. Don't litter.
Yes.
Try not to swim in lava.
Don't be a jerk.
Go visit Hawaii.
Yes. And when you go there, be a nice person. Don't be that.
Don't be a dick.
Yeah, don't be a jerk. And enjoy the volcano again. This is a really swell. So next month.
Yes.
What do we think is it going to be blooping like this? Is it going to be more? Is it going to be less?
I don't know. I kind of think that it's gonna bloop less, and I'm still betting on side pocket.
So I'm going to say that we'll have the lake will be smaller. There'll be a glowy bloopy spot.
Yeah.
But I think that the dough is going to rise up a bit more, make it harder for stuff to reach the surface. There might be a decline of the amount of energy coming into the system. So I would predict that the gas rates are going to be less than 3,000 tons per day.
Yeah.
Suggesting that not suggesting that the eruption is stopping,
right?
But that this eruption is not as vigorous.
It's flipping.
And this pond may be smaller, maybe have more like a little side pocket. It may not be as vigorously blooping as it does. But I would be surprised if it was stone cold, right?
Yeah.
That would be surprising.
That would be.
If the gas went down to just trace amounts next month.
We're going to check that off as Maanyaa's bet. Maanyaa's bet is that it's going to stop and be ice cold next month.
Yes. I would also be similarly surprised if Mauna Loa, if Mauna Loa erupted, right? Doesn't seem to have much way of earthquakes. Doesn't seem to be expansion there. So Mauna Loa seems to be in its pause state, but we may be back to a case where every 6, 7, 8 years typically it erupts again. So it appears. So that's what I'm guessing. Next month we'll have a spot where you can see glowy bits and little turnover bits, but that might be smaller. But the gas rates might be not 3,000, maybe, I don't know, 1,000 tons a day, be something, not zero, not as vigorous as it is, because the eruption is maturing.
Yeah, that sounds about right. I don't think I think too much differently. I think I'm sticking with my prediction from last month. I'm thinking it's going to be the same.
Eventually, and I think because you're right, eventually Chesh will be right in that the magma chamber will crust over and will find a drain spot, and I think on the longer term, because the old sinuses have been collapsed, right? That there's because of it's going to be easier for it to enter into those tubes and head one way or the other. But it's got to get a little bit. I think it's got to be a bit higher and got to have time to melt into the side. And if that happens, by the way, Chesh, if that happens, what we might see is the magma is no longer coming up on the top. So that might be the result of essentially almost no lava showing on the top because the magma's moving to the side. And we would see evidence of that because we'd see little earthquakes going down the line as the magma works its way down the line. We'll start to see those epicenters going down one crack or the other. Yeah. And that's because it's too much effort for it to come to the top.
It's going to go down.
Crust over. And so it'll push to the side some way or the other.
Yeah, I mean, I guess I can't say if it's I don't know if I would guess that that's going to happen next month, but I think in the relatively near future.
Yes, you would expect at some point this magma chamber is going to fill, crust over, have sort of a new level, and then it'll be easier for magma to work its way out the side than on the top. I would be surprised if that happened next month.
Yeah.
But if we saw several months of one, not much lava or no lava coming out the summit, and still lots of earthquakes, still lots of gas coming out, and still stuff from below coming into the chamber. Why? Because we'll see the tilt meters doing the DI events, but not lava coming out the top.
Right.
crossed over, that's probably when it'll eventually have to go someplace because it's still going to push up, but where's it going to go? It's going
Where's it
to
gonna
go
go?
to the side.
Yeah.
And the curiosity is how long does it take to evolve from refilling the magma chamber to the magma chamber starts
Yeah, it could be
pushing
years for
down
all we
to,
know.
yeah, we don't know, and it's going to be a time to see. So enjoy Kilauea,
Exciting.
and thank you very much
Thanks for
for there.
coming,
Any of the
Landon.
things you
What?
thank you very much as well, Chess. Any other things happening on your channel coming up
Yeah,
or?
we've got, let me look. Next week is going to be fly as hell. I've got Steven coming on to talk about video game development, and that's going to be great.
Ooh.
I also have Chris Shelton coming on with Bearded Heretic Luke, and we're talking about why reboots suck and the psychology of like basically Hollywood media. So that's gonna be a lot of fun. And then we have another Unnamed Tavern on that Saturday, if I remember correctly. And Maanyaa will
Yes.
probably be back, unless she decides to
Yes.
abandon us, which maybe she will.
We believe Maanyaa might have moved from the black hole quantum tunnel into a volcanic vent and maybe exploring things
I'm pretty
inside.
sure that's what she's doing.
But can you introduce us to this wonderful little critter on the side?
This is a blooper.
Ah.
These are little squid monsters, the creatures from Mario.
Ah. It's a blooper, and
His name
it's
is
got a
Blooper.
nice. I like the eyes. The eyes are particularly.
I would ask everybody
Fun.
to do me a favor. I have some fun artwork to do on Thursdays, and I would like to do a magma version, like a volcanic version of a blooper.
Ooh.
I think that would be fun,
Ooh.
right?
Yes, there you go. Very go.
We
Very
have some
good.
fun
So,
stuff set up
so
for
folks,
Thursday.
continue there. Working on with my producer on a set of videos regarding relativity, principles of
Ooh.
relativity, without all the heavy math, without the, as Feynman said, the language of the priesthood, but simply explain. I did a very successful delivery of that. We did an hour presentation to the high school students up in
Yes.
Canada, and I twisted their minds, showing them what they thought was real was not real, and vice versa. So I look forward to that being produced. Right now, I have a producer who is building a current set of illustrations.
Ooh.
And this producer uses lots of tools. One of the things the producer is planning on doing is using these machine learning tools to guide it in generating art.
The AI art discussion.
We need to have an image of a cat out in space glowing, and as part of the thing. And so this person's capable of doing themselves, but they use tools. And
Sure.
one of the tools they want to use is one of these tools that you can say things to it, and it will produce something, and you say, yeah, but blah 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 blah, and try to guiding it in there. So it's like a Photoshop, but on steroids. So
something like that.
See.
Yeah, I think that you need to use a tool before you can judge it. So
yes.
Let's see.
Anyway, so thank you very much, folks, for coming along, and keep a watch on what Kilauea is doing. You can laugh at us as Madam Pele decides to do what she's going to do, because whatever we predict doesn't amount to hill of beans. Pele dances to her own tune.
There are a ton of shows next week featuring Landon. Like and subscribe. Go find Landon wherever Landon is. Links are down below as well.
And consider giving a thumbs up on this thing, if you please. Also, Chesh has a Patreon.
Oh yes.
You can feed your artists, right? It's free, but a tip jar is produced. She also has a Amazon wish list, which is free of any Wizard of the Coast items, as I understand.
Yes, I've maintained that. It's going to stay that way for a while. We'll see if it ever changes. But
yes, so that same thing. Dapper, good shows going on. Check out his stuff. His fun things.
This has been Debate Hub. Thanks so much for joining us, and share and subscribe if you learned something. And we'll see you guys next time. Bye.
Bye.